What's up guys, in this video we are going to continue with finding the derivative of a composite function, and this will be the last video related to this topic, right? So let's solve some more function. So here I'm going to do question number 3, and this will be same. Find dy by dx if the first sub question is y is equals to e raised to e raised to right 5x square 5x squared minus 2x plus 4. This is your first question, right? So what you need to do, given y is equals to e raised to 5x squared minus 2x plus 4. So what you can do is you can assume that u is equals to this whole term. You can find du by dx, and then you can find dy by dx. Sorry, you will find first dy by du, then you will find du by dx, and by chain rule you will get the final answer as dy by dx. But remember, in the last class we learned a different method, right? And we are going to use that method, right? So that is also a chain rule. So what we are going to do, we are going to write differentiating both sides with respect to x, right? So once you do that, what you will get, dy by dx is equals to d by dx of e raised to 5x squared minus 2x plus 4. And we know that derivative of e raised to x is e raised to x itself. So the answer would be e raised to 5x squared minus 2x plus 4, as this x part is a composite function of x. So we need to again find d by dx of 5x squared minus 2x plus 4. This is by chain rule, right? So we found the derivative of this e raised to 5x squared minus 2x plus 4, and we again need to find the derivative of this inner part, right? The x part. And the answer would be e raised to 5x squared minus 2x plus 4 into derivative of 5x squared would be 5 into 2x, right? Because this is of the form x raised to n, so the answer would be 2 into x raised to n minus 1. So 2x minus derivative of 2x would be 2, plus derivative of 4 or constant is always 0. So the answer would be 10x minus 2 into e raised to 5x squared minus 2x plus 4, right? This is your dy by dx. This is very easy, right? This is your answer. I hope you are understanding this, and if you have any doubt you can post this in a comment section. Let's solve the second sub question, and the second sub question is given as y is equals to a raised to 1 plus log x, right? A raised to 1 plus log x. Let me write this question again. So you have been given y is equals to a raised to 1 plus log x. So how will you start your answer? Given y is equals to a raised to 1 plus log x, right? Differentiating both sides with respect to x, we get dy by dx is equals to d by dx of a raised to 1 plus log x, right? And we know that d by dx of a raised to x is a raised to x into log a, right? We know this, right, by the second class. So this is of the form a raised to x, but here x is nothing but 1 plus log x. So this is a composite function of x. So we are going to write an answer a raised to x. So in this case, a raised to 1 plus log x into log a, right? This is the derivative of this part. And again, we need to find the derivative of 1 plus log x, right? So a raised to 1 plus log x into log a into derivative of 1 is 0, right? This is a constant. So derivative of 1 is 0 plus derivative of log x is 1 upon x, right? So the final answer would be a raised to 1 plus log x into log a into log x. Sorry, into 1 upon x into 1 upon x. So I can write here as 1 upon x. This is your dy by dx. So this is your answer. So the answer would be 1 upon x into a raised to 1 plus log x into log a. This is very easy, right? Let's solve the last example. The last example is y is equals to 5 raised to 5 raised to x plus log x. Okay, so given y is equals to 5 raised to x plus log x. This is very similar to the previous example, but instead of a, we have here 5. And as you know that in a raised to x, a is nothing but constant, right? Also, a should not be equal to 1. Remember this. So here, a is nothing but 5. So we are going to write that same old statement, differentiating both sides with respect to x, we get dy by dx is equals to d by dx of 5 raised to x plus log x, right? So what is the derivative of a raised to x? Is nothing but a raised to, which in our case 5 raised to x plus log x into log 5, because a raised to x derivative is a raised to x into log a. Here as a is 5, so into log 5 into d by dx of x plus log x, right? This is as per chain rule, right? So the answer would be 5 raised to x plus log x into log 5. And if you find the derivative of this term, the derivative of x is 1 plus derivative of log x is 1 upon x, right? Pretty much easy. So your answer would be 1 plus 1 upon x into log 5 into 5 raised to x plus log x. This is your dy by dx. So this is how you basically solve the derivative of some of the composite function. We have seen about the log composite function as well as the algebraic composite functions, the square roots, the cube roots, and then we have also seen of the form a raised to x, right? Where the x is a composite function of x. So this is all about the finding the derivative of a composite function. In the next class, we are going to start a new topic where we are going to find the derivative of an inverse function. And I'm very excited. And if you have any doubts, questions, and if you have any feedback, you can share it with me in the comments. I'll be very happy to address those. And also to note that once we're done with this differentiation chapter, we are going to solve the previous year's questions which has come in the question paper of HSC board, right? 12th HSC board of commerce, right? So we'll meet you in the next class. Till then, goodbye and see you.